Now I am going to discuss about the lecture number 5 in units, dimensions and measurement. Now we will discuss about the significant figures and rounding of conditions. Significant figures, rounding of conditions. Before going to discuss about the significant figures and rounding of conditions, I will explain like what is the meaning of accuracy and precision. First, I will let the accuracy. As per the accuracy, you can see accuracy is nothing but whenever you are measuring anything in any measurement, in a measurement, if any measure value is there, that measure value is close to the true value. We can say that measure value is accurate value. In a measurement, if the measured value is close to the measured value is close to the true value, we can say that value is accurate value. Accurate. Okay. Similarly, precision. What is the meaning of precision? Precision actually it gives that it gives the order of measurement. It gives order of measurement. If any value is there that we are measuring, we can measure with the different instruments. Okay. Actually, this precision gives the limit of resolution in measurement that is related to the given instrument. Okay. If more number of decimal places are there, we can say that more precision. If more the number of decimal places, more will be the precision. Okay, suppose if I measure that any true value, let us consider true value of any measurement is I am taking like a 23.456. This is a given value. So let us consider this centimeter. Length of any object is this much is given. Now a student is measuring like student 1, he measure like this. Student 1 measure like a 23.45 centimeters. Student 2 measures that 23.456 centimeters. Student 3 measures that 23.4567 centimeters. If you observe all these three readings, student 1, whoever measures that, he measure up to 2 decimal places. But if you see here, how many decimal places are there? 3 decimal places are there. Okay. But 23.456 is there. Okay, and it is having 5 digits are there. Here only 4 digits are there. So it is not accurate. Not accurate. Not precise also. If you see this 23 point student 2, 23.456 centimeter is measuring. So 23.45 centimeter is closest to the, it is actually true value only. So most accurate and precise. Now you can see that last student number 3. Student number 3 is not accurate, not most accurate, but it is more precision. You can see how many decimal places are there. 4 decimal places are there. That's why it is most precise. Out of all these 3, student 2 reading is more accurate, student 3 reading is most precise. Observe this carefully. What I am going to say is, if true value, measured value is close to the true value, we can say that reading is most accurate. If measured reading, whatever measured reading is having more number of decimal places, means we can measure by using any instrument up to 4 decimal places by the student number 3. Okay, so he can measure up to 4 decimal places. Nothing but the precision value is more as comparatively student number 1, student number 2. Comparatively, whatever they device they have used, that whatever instrument they have used. So comparatively their instruments, student 3, whatever instrument he has used, that one is can give the most precise result. Okay, limit of resolution is 4 here. 4 decimal, up to 4 decimal places are there. Observe this carefully. What is the accuracy and precision? Okay, now I will give the more examples and relation also. Just I am showing this, what is accuracy and precision of instruments. We can see the numerical values of obtained on the measuring physical quantities depending on the measuring instruments methods of measurement. We can see what are the values. Accuracy refers to how closely measured value agrees with the true value. Precision refers to what limit of resolution the given physical quantity can be measured. Okay, precision refers to the closeness between the different observed values of the same quantity. Now, instead of getting all these points, you remember that more decimal places, more will be the precision. That's all. And high precision does not mean high accuracy. A true value is 2.250 centimeter is there. Student A, B, C, they are measuring. So measurement 1, measurement 2, measurement 3 are there. We can see average length also they have, it is pasted here. 2.26, 2.51 centimeters, 2.250 centimeters. Out of these 3, you can see student B and student 3 both are measured up to 3 decimal places. Both are more precise only. B and C are more precise. Next, student A, if you see that less precise, and which is nearest to the closest value, true value. Nearest value is we can see that student C. C is most accurate. This is the meaning of precision and accuracy. Next, I am going to give the significant figures. Significant figures meaning is, let us consider that we are taking a scale. In this scale, I am measuring any object. This is the object. A scale is there up to certain length. We can see it is 0. Let us consider this point is lies between this. Let us consider the value of the object is 5.6 centimeter to the 5.7 centimeter. It is lies between 5.6 and 5.7. Not exactly 5.6, not exactly 5.7. In that case, what is the what can be the result? We can see 5.6 is confirmed. It may be 5.61. It may be 5.62. It may be 5.63. It may be 5.64. It may be 5.65 or 5.67, 66 up to 5.69 you will write. Now you can see in this reading from 5.6 to the 5.61 to 5.69, we can see 5.6 is a certain values. It is certain. Last two digits are there now, they are uncertain. Okay. Now significant figure is nothing but you can see that conformly you can say that by using any instrument you can get the this instrument we can get the values are like a certain digits are there and one uncertain digit. The combination of certain digit and uncertain digit is called significant figures. Okay, I am writing what is the meaning of significant figure. Combination of certain digits and first uncertain digit. First uncertain digit is significant figure. Okay, I have taken here what is some condition for significant figures. We can see if you take pi is you can take up to so many digits also. If you take up to 10 digits we are getting one result. If you want to take up to 3 digits also you can take. If you want to you can take up to 5 digits also. Okay, 3.1416. Significant figures indicates the extent to which the readings are reliable. Up to what reliable we can take. Maybe in case of the pi, it is a number. Number will have like any number if you take no, that number will have infinite significant figures. As per the given situation, we can take up to 5 digits also. We can take up to 10 digits also. We can take up to 3 digits also. If you want to, you can take up to 2 digits also. Okay, a number will have infinite significant figures. Okay, I am writing a number will have infinite significant figures. Okay, as per the situation you have to take. Okay, number here you can see pi can take up to the 10 digits also, up to 3 digits also, up to 5 digit also. As per the question you have to follow that. As per the remaining measured values will be there, no, based on that you have to follow. Now you can see there are the some rules are there to determine the significant figures. We can check that rules. All the non-zero digits have given number significant without any reading to the location of decimal point, if any. Now you can see in this case 18452 is there. How many digits are there? There are the 5 digits are there. All 5 digits are significant only. Similarly, next digits also 1845.2 is there, as well as 184.52. All these are having 5 digits only. All non-zero digits are significant. First point is that. Okay, next one, if any zeros are lies between numbers, non-zero digits, they are significant. We can see in this case 106008 is there. Total how many digits are there? 6 digits are there. So you can say 6 digits are the significant figures here. Okay, similarly if you take that, if a number is less than 1, if a number is less than 1, nothing but 0 0.1, 0 0.01, some values are there, no, 0 0.7, 0 0.6, all will come under the value is less than 1. Now whatever the number is there, like left to the non-zero to digit, whatever the left to the non-zero digits are there, no, they are non-significant. Okay, in this case we can see only 308. Before that whatever zeros are there we can forget about that. Only 308 is there, no, that is a significant. We can see here 3 significants are there. All the zeros right of the decimal place like a are significant. Now you can see 30.00. Here significant is 4. This we can say that if a number is greater than sorry, it is not number actually. If measured value is greater than 1 and having decimal places. In that case, all zeros appearing right to the non-zero digit are significant. Okay, now you can see that 30.00 is there, that 30.00 having 4 significant. Okay, similarly you can see that all zeros to the right of the last non-zero digit also significant. 0.05600 is there. In this case, after decimal place, whatever the zeros are coming at the end, okay, 5600 is there. Now after 6 non-zero digit, there is a 2 zeros also there, that will come under the significant only. Okay, 5600 having 4 decimal places. All zeros right to the last non-zero digit in a number having no decimal points are not significant. So if it is there 2030, this 2030 has significant digits are 3 only. Reason is, suppose if I take like a 1 centimeter is measured value is 1 centimeter. Okay, now number of significant digit is 1 only. Same thing, I can write this as 0.1 millimeter also. 0.1, sorry, I wrote wrong. I can write this one is 10 millimeter also. So my measured device is there, no instrument that is measuring in terms of the centimeter. Okay, that it can give like a 1 centimeter, 2 centimeter, 3 centimeter, like that. Nothing but here significant is 1 digit only. Okay, if I get the same value, if I want to write in terms of the millimeter, same 1 centimeter can be written as 10 millimeter also. So if I write the 10 millimeter, I cannot increase the significant digits are like a 2. I should write only significant digits are what here 1 only. That's why order of magnitude will not have any significant. I am writing here one of the relation, order of magnitude means powers of 10 is non-significant. Remember these points. Okay, now we will see other points. Rounding of numbers. Okay, rules for rounding of numbers, rounding of conditions also you can take. This is basic things only, just to show only I have written here. Suppose if I say that 4728 is there. If you want to round off this to the 3 significant figures. 3 significant figures means the number to be dropped is 8. 8 is greater than 5. So presiding digit is there, not 2 will be raised by 1. Okay, presiding digit will be raised by 1. Digit will be raised by 1. If presiding digit is raised by 1, what is there here? Presiding digit 2. 2 should be raised to the 3. So now 4730. Now 0 is non-significant. That's why we can write in 3 significant. Okay. If you want to write in 3 significant figures, we'll get the 4730. Similarly, if presiding digit to be left unchanged if the immediate significant figure digit to be dropped is less than 5. Suppose say now if you want to drop is 3. 3 should be dropped to get the 3 significant figures. 3 is less than 5. So you can get the 4720. So now 472 is a number. Actually you can write the 4720. Okay. If the immediate insignificant digit, whatever digit is there, if you want to drop this, suppose say 4.7253 is there. If you want to drop dropped digit should be like a 5 here. Okay, uh, 2 decimal places only you want. If dropping digit is 5 is there, then preceding digit will be raised by 1 cases, and other cases we can see that preceding digit will be raised by remains same. When it will be remain same, and when it will be raised by 1. We can see here dropping digit is 5. If dropping digit is 5, if preceding digit is even, then preceding digit will not change. In this case, 4.7253 is there. Dropping digit is 5. Now preceding digit is even. So we can write it as 4.72 for 2 decimal places. Now if you take that 4.7153 is there. Now if the dropping digit is 5, preceding digit is odd, 1 is odd, then it will be raised by 1 digit. So you can write 4.72, it will become 4.72. If it is odd, it will be raised by 1. If it is even, preceding digit is even, it remains same. Next one, rules for arithmetic operations with significant figures. This you have to keep in your mind while multiplying, while subtracting, while dividing to measured values, while adding to measured values. You can see here 2 or more in A also. Now while multiplying or while dividing, you can see here in this first case we can see significant figures. We have to see 2 significant figure is there in 1.2. In 2.54 we can see that 3 significant figure is there, and in 3.26 we are having 3 significant figures. If you multiply all the 1.2, 2.54, 3.26, you will get the 9.93648 we are getting. But after multiplication of the any measured value, or after dividing any measured values, final result should contain only least significant figures of that operation. Which is having least significant here? We can see 2 is the least significant. 2 significant figures we have to get. To get the 2 significant, 9.93648 we have to round off into the 2 significant figures. Then 3648 number is dropped. Whatever dropping digit is there 3, that is less than 5. So finally we will get the 9.9 is the answer. Similarly, same thing you can apply for the division also. Okay, while multiplying and while dividing, you have to see that final result should be least significant figures of whatever the values are measured values involved in that operation. Here 1.2 is having least significant 2, that's why final answer should be 2 significant. But in case of addition and subtraction, we have to see that you see properly here 2.2 2.2 is 1 decimal place, 4.08 is 2 decimal place, 3.12 is 2 decimal place, 6.38 is 2 decimal place. Finally if I add all the things, 15.78 I am getting. Now 15.78 is having 2 decimal places. Okay, now in this, which is the least decimal place having? You see here 2.2, it is having 1 decimal place. My final answer should be containing only 1 decimal place. Now to get the only 1 decimal place, 8 to be dropped. If I drop the 8, then you can get the 15.8 is more than 5, we'll get 15.8. This is my answer. Finally, what I am going to give the conclusion is, if any measured values are multiplying or dividing, if they are participating in multiplication or division, we have to see only significant figures. Final result should have the least significant of measured values participated in that operation. Whichever having the least significant, that you have to take. Similarly, in case of addition and subtraction, we have to see that whichever the measured values are there, that measured values you have to see least decimal places there. No, that should be the our final answer also should contains the least decimal place of that operation in that measured values which is participated in that operation. Okay, here 2.2 is there, no, that is having only one decimal place. Final answer should be one decimal place only. Okay, now we are going to see that questions. We can see the respective number of significant figures for the numbers 23.023, 0.003, 2.1 into 10 power minus 3. I am writing one by one. 23.023, you can see that number of significant digits are 5. Next, if you take 0.003, number of significant digits are only one digit. Why only one digit is there? So it is number is less than 1. And we can see all zeros are there. Whichever digits are there before the are left to the non-zero digit are non-significant. We can see non-significant or insignificant. We can see only one digit you will get. Last one, 2.1 into 10 to the power of minus 3. In this case, we can see order of magnitude is there. 10 power minus 3 is order of magnitude. Order of magnitude is insignificant. Now, which digits are there? Now, only 2 digits are there. Finally, you can get the number of significants are 2. So, second option is the correct option. Next question, we are moving to the next question. You can see, I have taken already this question. The diameter and height of the cylinder are measured by meter scale. 12.6 plus or minus 0.1, 24.2 plus or minus 0.1 respectively. What will be the value of volume in appropriate significant figures? You can see everyone knows that what is the volume of any cylinder. I have taken the volume of cylinder is V is equal to pi r square h. As r is equal to d by 2, you can write it as V is equal to pi into d by 2 whole square into h. So that you can write it as pi d square h divided by the 4. I am substituting the given values like what are the d value 12.6 is there and h value is 34.2. If I substitute the value, I am getting like a 4264.39 centimeter cube. But if we see all options, we are having like a 4 digit type is there and some are point also there. What actually how to see here? If you see that 12.6 is D and H value is equal to how much? 34.2 is there. This is having 3 significant figure, 3 significant. And 34.2 also having 3 significant. Now, our answer should have like a whatever volume you are calculating, no, that should have only 3 significant. I am replacing into 3 significant. First you can see that 4 also should be dropped. 4.39 is there, no, that should be dropped. So to get that 4260 centimeter cube should be my answer. 4260 should be my answer. So I can write the 426. Again, anyway, you can check the error also. You know that relative error in volume is delta V by V is equal to 2 into delta D by D plus delta H by H. Substitute the delta D value is 0.1, delta H value is 0.1. If you substitute all values, delta V value 1, this V value is that you substitute here. If you substitute the V value, finally I am getting like a 80.157. That everyone can do this value. 80.157 centimeter cube you are getting now. You just observe that our result, if you see our result, delta whatever the delta D is there, it is having 0.1. Delta H value is there, this is also equal to the 0.1 centimeters only. Now how many number of significant is there? One significant. This also one significant only. My final result should be having only one significant. To get only one significant, I have to write only 80. Okay, which option is there? 80. Only one option is there, 80. Second option also there, but you will take only second option is having like a only two significant. 4300 is then only two significant will be there, but you want like three significant. Okay, third option is the correct option. Kindly check this question. Okay, now we are moving to the other question. The area of the square is 5.29 centimeters square. The area of 7 such squares taking into account the significant figure is what? Now you can see one area is 5.29 centimeters square is given. 7 such squares are like a 7 into 5.29. Same thing I have done. We got like a finally 37.03 centimeters square. But if you see that our result is then 5.29. 5.29 is having 3 significant. So finally you should get like a 3 significant only. But answer is one of the option is there 37.03. But you should not write that. Okay, you should write like a 3 significant digit only. The 3 significant digit is a second option. Kindly check that. There is a chance of getting like a negative mark here. Observe carefully. You have to get the 37.0 centimeters square only. Okay, next question you can see, this is a 4 sets are given, a1 b1 c1, all values they have given, a1 value, b1 value, c1 value. Similarly a2 b2 c2 is given, a3 b3 c3 values are given. Similarly a4 b4 c4 values also they have given. If you add all the a1 plus b1 plus c1, I have added which of the values are actually you can get the result you can see here. Earlier I told that whenever adding, while adding, what you have to consider, tell me, while adding, final answer should contain only least decimal places involved in least decimal places of measured values or measured value involved in operation. Now you see in first case C1 is least decimal, 1 decimal. Okay, second case we can see 1 decimal. Third case we can see 1 decimal. Answer should be in 1 decimal only. Last case we can see no decimal. It should be number. Okay, now you check that if I add a1 plus b1 plus c1 values, I am getting 280.6324. Now I have to round off this into the single decimal place. So 3 is to be dropped. 3 is less than 5. If it is less than 5, we can write it as 280.6. Next case, if I add 280.722, we are getting the number to be dropped is 2. 2 is less than 5. Finally, we'll get 280.7 only. Next, third case, we can see that number to be dropped is 6. 6 is, we can write it greater than 5. Preceding digit will raised by 1. Now 6 becomes 7. So we can write 280.7. Third case, fourth case, A4, B4, C4, if we add, 280.69 is there. Now we have to drop 6 only. No decimal place, no least value. Dropping digit is more than 5. Now preceding digit will raised by 1. So this 0 becomes 1. I have written 281, I have written. Okay, you can check that. If you observe these values, last fourth condition is there, no, A4, B4, C4. That is more than the third case. Third case and second case both are almost all, not almost all. 3 and 4 are, 3 and 2 are equal only. And first case is least value. You can see which of the following is correct. Third option is correct. A1 plus B1 plus C1 is less than A2 plus B2 plus C2, that is equal to A3 plus B3 plus C3, less than A4 plus B4 plus C4. Okay. Now I am moving to the next question. You can see next question is like this. A student is measuring something. Here they have given some terms like a standard deviation of the data is given, and the average values of these 4 values they have given. 5.5375 is given. Here in this question, we no need to calculate anything. They only given average values as well as standard deviation of the data. Okay. First of all, I will tell what is the standard deviation and all this. Okay. Listen carefully. If in any case, there are the measured values are like this. A1, A2, A3, AN are measured values. Okay. Now, errors in that values are, above values are, consider the delta A1, delta A2, delta AN like that, up to delta AN. Now, if you want to calculate the absolute error, there are 2 methods are there. To find absolute error, there are 2 methods. First method is average method. In this average method, we can write it as delta A mean value is equal to delta A1 plus delta A2 plus so on up to delta AN whole divided by the n you will write. That is one method, average method. Second method is standard deviation method. You can see standard deviation method. What is the meaning of standard deviation method? Here absolute error delta A can be written as under root of delta A1 square plus delta A2 square plus so on plus delta AN square whole divided by the n. Like we are taking like a RMS value. It is like a RMS value. Taking the RMS value of any error gives the standard deviation method. Finding any error in standard deviation method is nothing but you have to take the RMS values of all the errors. I hope it is clear for you. Just I am moving to this question. You see in this question, student measuring the diameter of a pencil circular cross section with the help of a vernier scale regards the following four readings: 5.50 millimeter, 5.55, 5.45 millimeter, 5.65 millimeter. The average of these four readings are they given already, so no need to calculate this. They have only mentioned that what is the average value, 5.5375. But if we see in these all values, all measured values are having how many decimal places? Only two decimal places. I am writing all measured values having two decimal places. Only two decimal places are there. But our average value is containing how many decimal places? Average value is four decimal places. We need to reduce that four decimal places into two decimal places. If I reduce the 4 into 2 decimal places, 5.5375 is no. The dropping digit should be 7. It should be dropped. To drop the 7, the preceding digit should be raised by 1. Nothing but 7 is having more than 5. That's why we will write the 5.54 should be our result. Where 5.54 is there? Only second option is there. Similarly, and the standard deviation of data, standard deviation method is actually you can calculate to get the value of error. Okay, error is we can see that 0.07395 is there. So here how many decimal places are there here? We can see 1 2 3 4 5 5 decimal places are there. 5 decimal places. But you don't want these 5 decimal places. 0.07395 is there, no? 7395. In this one, the dropping digit should be 3. Should be dropped. If I drop the 3, 3 is actually less than 5. So preceding digit will not change. 0.07 only will get. Preceding digit will not change. So our answer is a second option. Now you can ask like I have given only error. Error absolute error can be find by using two methods. One method is like a average method. Second one is a standard deviation method. Okay, but if you see that they are not this 5.5375 is there, no, that is not the error. Understand that 5.5375 value that is a true value. True value also we can write like general method only, no. Okay, like a1 plus a2 plus a3 plus an divided by the n. By using that we can calculate the average value. But anyway, here no need to calculate anything. Just you have to use the rounding of conditions and significant figures rules are there, no, that you have to follow. And here also I have written data. You can check that. Okay. Next one, I am moving to next question. In this question, it is a simple pendulum. In the last lecture also, I have explained that how to calculate the time period of simple pendulum. In this question, they have given length is given 20 centimeters and accuracy in length also given. I am writing here delta L is equal to 1 millimeter. 1 millimeter is 0.1 centimeters. L is given that 20.0 centimeters. Now error in time is given that delta t is equal to 1 second and time taken they have given 90 seconds. T is equal to 90 seconds. Now you need to calculate delta g by g into 100. You know that t is equal to 2 pi root over L divided by the g. That in question also they have given t is equal to 2 pi root over L by g. Now you can square on both sides. So you will get g is equal to 4 pi square L divided by the t square. Now error in this g. Delta g by g into 100 is equal to delta L divided by the L into 100 plus 2 into delta t divided by the t into 100. But you know that time is t divided by the n. You can write the delta t by t into 100 can be written as delta t divided by the t into 100. Same thing you can write here, delta t divided by the t into 100. You substitute there. I can get the value is delta L by L value is 0.1 divided by the 20 into 100 plus 2 into delta t by t into 100. That value we can write as 1 second divided by the 90 seconds into 100. You calculate the value, you will get the approximately answer is 1 minute. I will calculate this. Actually, I pasted for that purpose only. 0, 0 get cancelled. So we can get the 10 by 20, that value is 0.5 percentage plus 20 by 9. 20 by 9 percentage. We can see 0.5 percentage plus 20 by 9 is 2.2 percentage approximately. We can get the 2.7 percentage. You observe this carefully. But if you see, they are asking G value only in particular value. Here 2 percentage, 3 percentage, 1 percentage, 5 percentage. They are asking up to one decimal, one digit only. If I want to write in one digit, you can see 7 should be dropped. If I want to drop the 7, 7 is less than the, more than the 5. Now preceding digit will be raised by 1. So 3 percentage will get. Okay. So answer is the second option. Now I will move to the next question. We can see next question also related to the same time period of a simple pendulum only. Here also we can calculate the t mean value they are asking. Here t mean value can be written as all the values, whatever the 90, 91, 95, 92 whole divided by the 1, 2, 3, 4 digits are there. That 4 we can write. Anyway, in all answers they have given 92. We can write 92 directly. Next, we can see that what is error in that. So we can see that delta t, I am writing small delta t. T, small t, and delta t also I am writing. You can say 1 second. Now delta t divided by the t is equal to how much? Delta t divided by the t value is equal to how much? Okay. Delta t value is how much now? We can write it as delta t value is 1 second. T value is equal to how much? 92 is there. Now you need to calculate reported mean time is equal to how much they are asking. Measuring clock they have given now. You need to calculate the what is the mean value. Okay. They are not asking this actually. They are asking mean value. Just calculate the mean value. Mean value can be written as in first case delta t1 value is equal to how much? Magnitude of 92 minus 90. Delta t2 value will calculate magnitude of 90 minus 91. Delta t3 value will calculate magnitude of 92 minus 95. Delta t4 will calculate magnitude of 92 minus 92. You will get some values like a 2, here 1, here 3, here 0. You calculate delta t mean value. Delta t mean value can be written as 2 plus 1 plus 3 plus 0 whole divided by the 4. You can get the value is 2 plus 1 is 3, 3 plus 3 is 6, 6 by 4. 6 by 4 is 3.2 we can write, that value is 1.5. Now you check properly, our clock is having 1 second only, nothing but whatever the precision is there, 1 only, nothing but the digit you can measure up to only 1 second only. 1 second is nothing but least value is 1 second. In this measurement you may get the value, least value is 1 now, so more than 1 also you may get values while measuring. Understand that least value should not be less than 1. That is the meaning actually. Now you can see 1.5 is there. I need to drop the 5. If I drop the 5, preceding digit is 1 here. So I should get the 2. Okay. So answer is how much at fourth option. Actually I have taken to show that how to drop this 5. Okay. We will move to the next question. This question is previous, this is the last question. There is a previous JEE advanced question 2016 paper 2 they have asked. Here They are measuring the acceleration due to gravity. Time period of a pendulum is given that t is equal to 2 pi under root of 7 root over r minus r by 5g. R values and small r values are given. Remaining values also they are given. Just you will see that. You can also read the question. I am moving to the answers. The error in r value is equal to how much? You can see r value, you can see 10 plus r minus 1 millimeter is given. What is the error in delta r? Percentage error delta r by r into 100. Delta r is 1 millimeter divided by the 10 into 100. You can get the 10 percentage. So first case you can see that A option is correct. Next one, the value of t, error in t is how much? You can see you have to calculate first t mean value. T mean value I am writing 0 0.52, 0 0.56, 0 0.57, 0 0.54, 0 0.59 whole divided by the 1, 2, 3, 4, 5. 5 digits are there. You calculate this value. I am not calculating here. You just calculate. You will get some seconds. Okay. After that, you will get like a delta T1 value. What is a delta T1 value? The measured value, whatever the measured value you are getting, that you have, anyway, you need answer now that I am writing now. 0.52, 0.56, 0.57, 0.54, 0.59. If you add all the things, 8 plus 7, 15, 15 plus 4, 15 plus 4, 19, 19 plus 9 is 28. Again, 1, 2, 3, 4, 5, 25, 27. So 2.78. 2.78 divided by the 5. So you can get the 0.5 and you can see that again 0.5 and 2 is there 28. So you can write as again 5 times 0.55 will get. So just after that 2.78 divided by the 5 is how much? 0.27 is there 5 times, 28 is there, you can get the again 5 times, and 28 means already 3 is there, 0.556 is there. Actually you can write 0.556, but you don't want these many 3 places, we want only 2 places. That's why I'm getting 0.56 second is my value. Okay, now why? Because dropping digit is 6. Delta T1 value is equal to how much? We can write a magnitude of 0.52 minus 0.56. Similarly, delta T2 value is 0.56 minus 0.56. Delta T3 value will write 0.57 minus 0.56. Delta T4 value will write 0.5754 minus 0.56. And similarly, delta T5 value is there, magnitude of 0.59 minus 0.56. If you write the value is 0 will get in first case is what here, 4 will get, second case 0 will get, third case if you write that 1 value will get, fourth case will get 2, fifth reading you can get the 3. If you write the delta T mean value, delta T mean value is 4 plus 0 plus 1 plus 2 plus 3 whole divided by the 5. Now you can write the 4 plus 1 is 5, 5 plus 5 is 10, 10 divided by the 5 is equal to 2. Okay, you are getting the value is 2. 1 minute wait, I wrote like all values are 0 0.02, 0.03. Here also 0 point is there, everywhere you write 0 point. If you write 0.03, I will write again, otherwise you will get confusion. Delta T mean value 0.04 plus 0.00 plus 0.01 plus 0.02 plus 0.03 whole divided by the 5. You can get the value is 0.0412 so 0.10 divided by the 5, 0.20 will get. This is my T mean value. Okay, we can see the value of T mean is this. You calculate the T value is 0.04 2 divided by the 0.56 term is there now, that you calculate, you will get the value is B option. Similarly, after getting that, I will get or not to check that, delta T mean divided by the T mean into 100, that value is 0.2, 4 plus 2, 6, 7, 10 only now. So 0.10 is there. So 10 by 5 is 2. Okay. 1 minute wait. It is not the 0.20. You can get the delta T mean value is how much? 10 into 10 power minus 2 divided by the 5. That is 2. You can get 0.02. Okay. You write 0.02 into 100 divided by the T mean value is how much? 0.56. Now you can get the 2 by 0.56. 2 by 0.56 means 200 by 56. 200 by 50 is 4. So approximately you will get given value. You can check that 3.57 will get. So 3.57 percentage is the T mean value. I got the T mean value. Now G value you have to calculate. How to write G value? Earlier we have written G value is equal to how much? I am writing in next page. G is equal to 4 pi square L divided by the T square. If G is equal to L divided by the T square, delta G divided by the G into 100 is equal to delta L by L into 100 plus 2 into delta T by T into 100. Substitute all values. Delta L by L into 100 is there. Oh, sorry, 1 minute wait. I wrote G value is not this now. We have to follow as per the question. T is equal to given 2 pi into T is equal to 2 pi root over 5 into R minus R whole divided by the 5G. Now you can square on both sides. T square is equal to 4 pi square 5 into R minus R divided by the 7 into here, not the 5 into 7 into. Okay, here also we read the 7 into divided by the 5 into G. You can write the G is equal to 4 pi square into 7 divided by the 5 is there. Next R minus R divided by the T square is there. We want this terms actually. The percentage error in G is equal to how much? G by G into 100 is equal to delta R minus R whole divided by the R minus R plus 2 into delta T by T into 100 is there. You can write into 100. Now you can write delta R. You see here, delta R minus R can be written as delta R, error in capital R, error in small r. So error in small r minus R into 100 plus 2 into delta T by T into 100. I hope values already it is given. I calculated the values also. Capital R value is 60, error in 60 is error in capital R is 1. So small r is equal to 10, error in this value is 1. You substitute there. Delta R is 1 plus 1 divided by the R minus R. 60 minus 10 into 100 plus 2 into delta T by T into 100. We have calculated the value is 3.57. 3.57 percentage. If you calculate the value, you will get the some result. You will get that result we are going to see now. 2 divided by the 50 into 100 plus you can get the 3.57 into 2 is 4, 2 5 is 10, 11 and 6 7. Here you will get the 2. So finally you will get the 4 plus 7.14. You will get the 11.14 percentage is the delta G divided by the G into 100. But our final results, if you say, they have given 11 percentage. Why we should get like 11 percentage? Reason is whatever the G value is there, that G value they are taking like a without any decimal places. If you round off this into the nearest two-digit number, you will get the 11%. It is 11% as per the question. Okay, that's it. I hope you have enjoyed this. You can subscribe this. You can like. If anything is there, you can comment also. Okay, and we can share to your friends also. If you see in the next lecture now, I will go to I'm going to explain about the whatever the other instruments are there, like vernier